For those who don't know me, I'm Vikas Desai. I am the Cybersecurity Advisor for IBM for Asia Pacific. Today I'm going to share with you a use case about using machine learning and natural language processing and understanding in the security space. This is a very interesting problem that we are going to see today, and it's a very interesting way in which it is being solved. Watson, I'm sure everybody has heard about it. Today we are actually going to see how Watson is being used in the security space. Right. Just a brief background about Watson for people who might not have heard about it. Watson is a machine learning, is an artificial intelligence which does natural language processing and understanding. It can actually understand the written English. It can read documents and make sense out of it. And today we are going to see how this is applied in the security space. Actually, this is how it's applied in the SOC space, Security Operations Center space. What I have right now in front of me here on the screen is a console. This is the state-of-the-art SIM solution available today. What you can see here is one incident that a SOC operator normally will see on his or her screen. This is normally what the screen looks like. The SOC operator will go through this incident, and as you can see, these are logs. So these are basically data which machines normally generate, and then a human being has to interpret them as to what exactly is happening in the organization right now. Now this is where the challenge becomes interesting, right? So this is machine-generated data. What the SOC operator has to do is the SOC operator has to go out and read reports, read lots and lots of security reports to kind of understand what's going on. To give you an example, when WannaCry was identified, it was actually identified via a blog. So if you wanted to understand what's happening in your organization, and if you wanted to identify WannaCry, as a SOC operator, you should have gone and read that particular blog about WannaCry, which was actually explaining what it does, what kind of footprints that it leaves around the organization. So the challenge here is that there are millions of reports, millions of security reports targeted towards human beings, which are generated every month. Now, for a SOC operator, for a SOC operation to be effective, they need people who would have gone through most of or all of these documents, right? Actually read them and understood them, and then apply that knowledge here to be able to figure out if the incident is real. If it is real, what to do about it. Can you just close the incident assuming everything is fine? Or if it's not, if it cannot be closed down, should I pass it to level 3? Should I go deeper into it? What exactly should I do about it? And that's the conundrum that this solution is trying to solve. So what you see here, as I said, is a normal incident, an offense, which has been generated as an alert. And as a human being, as a SOC operator, I would go through each one of this and then try to figure out. Normally, this exercise would take me anywhere from a few hours to a few days, right? Because I have to look up each one of these items and figure out what's going on. However, what I could do potentially, or what I can do here is, I can actually ask Watson to have a look at it and help me understand what's going on. And here, as you see, I'm actually submitting this incident, this offense, to Watson to analyze. Now, what Watson has done is this. Watson has basically learned and understood and read millions and millions of security blogs, articles, reports out there. And it's now going to apply that knowledge to this. And as you can see here, in just a few seconds, it has come back to us and said, you know what? I have analyzed 51 different parameters from this incident. I have found 34 new ones. So I have added to this incident. I have enhanced what the incident is all about. And I have actually identified that this is a WannaCry attack. Now Watson was able to do this because Watson has read the blogs and the reports on WannaCry and was able to apply that intelligence, that understanding of it, to this incident, which was basically some alerts generated by machines, by sensors all over the organization. Now let's see how Watson did it, and this is where it gets really interesting. The best part is Watson not only analyzes this for you, it actually shows you how the analysis was done. It actually shows you how it went from one user, Mary Arnold, who was actually showing some abnormal behavior, to the fact that this is probably a WannaCry attack. Attribution is something very challenging in most security scenarios. And this is where, as you can see here, that Watson has actually been able to build this whole knowledge graph gone from a user, Mary Arnold, to the actual perpetrator of crime, which is the WannaCry group, and basically have identified how it was done and where it was done. Not only that, you could actually click on this link, so click on this knowledge graphs, and Watson will show you exactly what information it has identified and how it is using this information. So yeah, you can click on each one of this and you can see that it's read some logs, it has read some blogs, it has read some reports to kind of derive this outcome. What Watson also does, and this is where it gets very interesting, what Watson also does is it basically shows you on the left hand side, it basically shows you what all various information, observables that it already had, and it has already enriched this. On top of it, it shows you the relationships between these guys. So what you see here is there's some local information, and then there is information which is enriched by Watson, which is in blue. And that is what Watson has applied. So this is the enriched information if you see here. And this was what it started off with. And this is basically taking out all the noise from the system. So you're taking out all the false positive alerts that are there and making this into a relevant, a valid incident that the organization can now act on. Right? So what you see here is basically a culmination of years of research in natural language processing and now being applied to security. What this does is it makes your SOC operator smarter. It makes your security operations center smarter, right? Not only does it now just have alerts and hundreds and thousands of alerts, it can actually address those alerts in a human way, right? So not only does it does the work for you, it also helps you train your SOC operators to be better at their jobs, right? So this is again another application of AI in the security space.